This is question 9, the last question on paper 2. You're given a right triangular prism and you're given a lot of information about the sides and the angles. In part A, you are asked to show that BF is equal to this third expression. So, if we consider triangle ABF, we can deduce that angle AFB is equal to 75 degrees. We need to find BF, so this calls for the sine rule. BF divided by sine of 60 is equal to 24 divided by sine of 75. Sine of 60, that's root 3 by 2. Sine of 75, that's root 2 plus root 6 divided by 4. Simplify this a bit further. Multiply by the conjugate. Root 6, that's root 2 times root 3. So, if we multiply in, we'll simply get 3 root 2 minus root 6. And this is the end of part A, 5 marks. Part B. The angle between the plane AEB and the plane ABCD is 65 degrees. What is this angle? AEB and ABCD. So, if we construct a line from E perpendicular to AB, and from here, draw a line that's perpendicular to DC, that would give us the angle that we're looking for. So, let's call this point M and this point N. We want to show that the length of EF is 7.1 centimeters. Let M be the foot of a perpendicular of F on AB. Let N be the foot of a perpendicular from E on CD. To show that EF is equal to 7.1 centimeters, we need to show that MN is equal to 7.1 centimeters. We also know that the angle between the plane AEB and ABCD is 65 degrees. This means the angle EMN is 65 degrees. So, first we need to find the length of EN, or the length of FN. And there are a lot of ways we can go about this. We just found the length of BF in the previous question part. Now we want to find the length of MF. So MF is simply equal to BF sine 45 in a right triangle FMB. And that would give you this length. This is equal to the length of EN. We also know that MN is the length to be found. So consider the right angle triangle EMN. Tan of 65 is equal to EN divided by MN. Therefore, MN is equal to EN divided by tan 65. And you should get the printed answer. Please make sure that your calculator is in degrees mode for this question. And you shall get 7.0600950 or 7.1 centimeters. Part C. Now we want to find the size of the angle between CF and the plane ABCD. First, let's locate this angle. CF and ABCD. Okay. I am going to erase these lines to make it a bit clearer. CF. We're still gonna keep part M from earlier. This is a right angled triangle. This is the angle we're looking for. To find this angle, you need to find the length of MC. We just got the length of EF from earlier. First, let's find the length of MC. So, if we consider the right angled triangle MBC, MC squared is equal to MB squared plus BC squared. Do we know the length of BC? Yes, it's equal to the length of EF. So you know you're on the right track because these parts are usually related to one another. MB squared. Look at triangle FMB. It is a right angled triangle. FBM is 45 degrees. Thus, MFB is also 45 degrees. And therefore, we have a right isosceles triangle. Thus, MB is also equal to MF. Therefore, MC is equal to 16.79 centimeter. We also found FM earlier, so the required angle FCM is simply arctan of FM divided by MC. And you will get 42.2 degrees as the final answer to 366. And this is the end of paper 2. I know this 3D trigonometry question is quite challenging, but I hope you find it useful.